I did not give you this question, I think. Here g of s is nothing but s plus 3, s plus 2, s plus 4 and s plus 5. What is the step response? This is the question.
1 over s.
Okay? This is your question.
So how to start this question?
You tell me what do you mean by step response?
1 over s, and
1
this
over s is what?
is. Oh, you mean the. Alright, yeah. So
What is
the
response?
respond is C.
C
C
of
of
s,
s.
right? And what is the step response? What do you mean by step response?
1 over s multiplied g of s.
C of s is R of s into G of s. Step response means your input R of s is 1 by s. Okay? Now
Yeah.
you can find it.
And then you multiply it and then find the
Yes.
fraction
Yes.
k1
Okay?
and k2 and k3.
Hmm.
Okay.
Now can you see the PPT?
Yeah.
Okay. Let's just start. Give me a minute. Hmm. So these things I've already told you yesterday. What is damping and what is the natural frequency of oscillation without damping. Okay.
Mm-hmm.
And damping, I told you that describes the damped oscillation. And what is the value? It is zeta by, because since in your in this you have been given yesterday. I told you alpha, right? Damp damping factor.
No, you
Okay.
told me zeta.
No. Zeta was damping ratio.
Yeah.
Zeta is damping ratio. So alpha is zeta omega n. So zeta is alpha by omega n. So you in your PDF, it is alpha is nothing but sigma. Okay.
Okay. Do I have to memorize this formula?
Let's see. I will tell you. Okay. So here we already discussed all these parts.
Let's discuss again when I told you I don't have any records from the past.
No. I discussed. I did not taught you. I did not teach you this slide before. I am telling you that I taught you these things yesterday.
Okay.
Okay. These things I have already told you that I found these values of this yesterday.
Yeah,
Right?
and I did understand that when I saw the
What
record.
what didn't you understand?
I did understand like everything about zeta and damping and whatever.
So you need rewatch it. Okay.
I did rewatch it. I did understand, so I left it. That's what I
So
did.
okay. So tell me what didn't you understand? Then I will tell you. Na. Otherwise, I will tell you the same thing which I taught you yesterday.
Then I guess I have to go over it again and again.
Yeah. Yeah. Okay. I have taught you how to find these roots yesterday. So I will tell you again the same thing. That's why I'm telling you that why to waste time.
Yeah, and do I memorize this formula or what?
Yes. Yes. If you see if you have the formula sheet, then you can write this on your formula sheet. Okay.
Okay.
These things yesterday we already discussed that when zeta is 0, then it would be your purely imaginary. When it would be less than 0 to 1, then you will have complex roots. When it is 1, then you will add repeated equal roots. Everything we already discussed it yesterday.
Yeah.
Okay. Now here, this is the question and you have to find the values. So here you see this is square plus 8s plus 12. Okay, what is the general formula? Omega n square. Omega n square upon s square plus 2 zeta omega ns plus omega n square, right?
This is the general formula, right?
Yes, general transfer function. And what I told you, you will always use the denominator part for comparing things, right?
Okay.
So take it K also here. So if you compare this with this is your question. Okay. So
Mhm.
x square plus 8s plus 12 equal to 0. You will compare this with this. So you see that 2 zeta omega n is 8 and omega n square is 12. So omega n is under root 12, right?
Yeah.
And zeta will be 8 upon 2 into under root 12. So it would be 4 by under root 12, right?
Yeah.
Now they have to you have to tell what to find the value of zeta and report the kind of response expected. So since this value would be greater than 1, if it is greater than 1, then you will say it is overdamped. If it is between 0 to 1, then you will say it is underdamped,
Yeah.
right? If it is less than 1, so you will say, sorry, if it is equal to 1, then you will
Let's
say it is
put them.
critically, right? So this is very simple. Now this is your question. Just compare this with s square plus 2 zeta omega ns plus omega n square. So you get omega n square is 60, which means omega is 4. Now 2 zeta omega n is 8. So 2 into zeta into 4 equal to 8. So you got zeta is equal to 1. So that means you have critically
How
damped.
did you get zeta equal to 1?
2 zeta omega n equal to 8. Zeta is equal to 8 by 2 into omega n. 8 by 2 into 4. This is 8 by 8, 1.
Oh, okay, okay,
Okay. Now this question you do it by yourself. Okay.
okay.
Write this formula in your formula sheet. This
Uh,
one.
yeah, I will just
This is
adjust
the
it.
this is the output for a step a response. This is a step response. Okay.
Okay,
So you do not have to do this one. You can use this one. Okay.
okay,
Or if you want, you can write both of them.
okay.
Now we already discussed that as you will increase the value of zeta, your oscillation will get lower. If you see here, your zeta value is 0.1. Okay.
Yeah,
And now, so oscillations are more. Now here you see zeta is 0.2. That means as you go downwards, your zeta is getting increased. So your oscillations are also getting decreased. Okay.
okay.
Now this one, you have rise time here. Rise time is what? As we discussed in the previous section, that the time taken by a step response to reach from 10 to 90% of its final value is your
Is
TR.
it the same as we discussed before?
Yes, but the formula will be different. Definition will be same, but formula would be different. Okay.
And how do I know which formula to use really?
If it is first order, then you will use TR is equal to 2.2 T. If it is second order, then I will tell you what formula is. It
Okay,
is pi minus pi by omega d. Okay.
okay,
Now peak time is what? The time required to reach the first peak of the maximum value. Now, if you see this graph, it is going like this and like this. Okay. So this is your first peak, right? This is your first peak. Okay.
okay,
So the time taken by your response to reach the first peak, this is nothing but your peak time. Okay.
okay.
Now, what is a percentage overshoot? Now, here, if you see, it increase from here and settle at its final value, right? Right?
Mm-hmm.
In your system, there is oscillation and it is settling like this. Suppose this is your C final value.
Yeah.
Okay. So the difference between your peak value and the final value is your overshoot. Okay. Overshoot, you can write in your copy that overshoot is CTP minus C infinity. Means this is what response at peak time, and this is your response at steady state, or you can say final value.
Okay.
Okay. So this is your MP. MP is what? The difference between your maximum value and your final value. This is nothing but a MP. Okay.
Yeah.
And as we discussed, what is settling time? As we discussed in previously, that the time required for the oscillation to die and stay within 2% of its final value. Okay, just like yesterday we studied, and this formula is always same. Ts is equal to 40. Okay.
Okay.
Now this is the, you can write these formula directly. I'm jumping to the formula. Write this formula in your copy.
Okay.
Tp is n pi upon omega d. Omega d is what? Omega n under root 1 minus zeta square. So if you're in the question, it is asked find Tp, then you will use this formula.
Okay. And what is TP again?
Tp is the time taken by the response to reach the to reach the maximum value. Okay.
All right.
And here you have one more formula. I told you MP is, I told you that MP is CTP minus C infinity, right? Okay.
Okay.
And I'm not telling you how these things. You can just write in your
Formula
you,
sheet?
formula sheet. OS percentage OS is this formula. Okay.
Okay.
This formula and this one formula, which is e to the power minus pi zeta upon under root 1 minus zeta square into 100. Right?
Okay.
Just give me a second, please.
Yeah.
Fine. And you can write this zeta formula also in your formula sheet. Hello. Hello. Are you there, Nawaz?
Yeah, I'm here.
Okay. So I'm saying that you should write this formula. This formula is very important. Okay.
Okay.
What would be the question like? Question would be like that you have been given percentage OS and they will ask to find the value of zeta. So which formula you will use? You will directly use this formula. Okay.
Okay.
So these are some formulas you just need to write in your formula sheet and directly put the values and find the final answer.
Okay. Is there a example I can see how you do it?
Maybe it will be there in your PPT, or if it is not, we will discuss it,
Okay.
right? First, let's discuss all the formulas, right?
Okay.
Here, the another formula is this one. TS for the first order system, we had TS is equal to 4 into T, right? And 4T was your time constant.
Mm-hmm.
And in second order system, your TS is 4 by zeta omega n.
Yeah.
You need to write all these formulas in your formula sheet.
Cool.
And I have already discussed these things, that if you have underdamped second order system, then what will happen? You will get complex roots, and you know how to plot the complex roots.
Yeah.
And as I told you that for underdamped, you have S12 is minus sigma d plus minus j omega d. So when you plot it, you have here and here, right? So this is your j omega d, this is minus j omega d, and this is minus sigma d. Okay.
Yeah.
What is the value of sigma d? Sigma d is nothing but zeta omega n, and omega d is omega n under root 1 minus zeta square.
Okay. And I really have a question from yesterday.
Huh? Hmm?
So let me just get it the PPT. Just wait.
Okay, okay, sure.
Yeah, I have it. So what's really the difference between when you say too complex and when you say too imaginary? What's the
Uh,
difference?
complex means complex means when you have real term and imaginary parts both. Okay. Suppose you have something like 3 plus 4j. So the number associated with j part is you called as imaginary number. Okay. And this one is your real part,
Okay.
right? Suppose you have z, let's take it is as z. So z is only 3. That means you do not have any j part here. So you will say that it is your real number,
Yeah.
right? And suppose if you have only 4j, you can say that this
Yeah.
is your purely real number, right? And if you have j is equal to 4j, so you see that there is no real term. You have only
Imagine.
j term. So you
Yeah.
will say that it is purely imaginary.
Yeah.
And if you have combination of both real term and imaginary term, then you will say
Complex.
that it is your complex number.
All right, got it. Thank you.
These formulas we have already discussed. Okay, here you can see that TP is, what is the value of TP? TP is nothing but 1 by pi by omega d, right?
It's this.
Right?
What is
And
why?
TS is 4 by zeta omega n. Zeta omega n is nothing but 4 by sigma d. Okay, so you can say that TP is inversely proportional to omega d and TS is inversely proportional to sigma d.
What
right?
that mean?
Let's see. It is only a interpretation we have done from these formulas. We will see in the question how can we use this information.
Okay.
Yeah, this one is very important. This slide is very important.
Okay.
Here, if you see that if you have, if you see this line, this is for constant zeta. Okay,
Okay.
and these lines, these straight lines, these are your constant peak time lines, and these lines are your constant settling time.
Okay.
Many questions come from this slide. If you have so any questions, we will discuss them. Okay.
Yeah, I don't know how to use this formula. So
I
can
will
you
I
please
will tell
tell?
you. I will tell you. If you have questions, then
I don't
send
have a
me
question. From where should I get a question?
you from your professor or from your book.
I don't have the book or anything.
Okay, no problem. I will tell you the question later, but because I don't have it right now. Okay.
Okay.
Now, you should remember this one also, that figures below show how the response of a second order system changes when the pole move on the S plane. If you see that your poles are moving in the upward direction,
Yeah.
so what happens? Your envelope, this envelope will always be same. When your poles move in the backward direction, in horizontal direction, then you will say that your frequency is same. Okay. And when your poles are moving in a diagonally, they are moving diagonally, then you will say that you have same overshoot. You need to memorize, or if you can write in your formula sheet, you should, because the question will come directly. Okay. Question will be like, suppose they have given, you have like this,
Okay.
and they will ask you to tell that whether it is same overshoot, same frequency, or same envelope.
Same
Okay.
overshoot, right?
So you will, yeah, so you will take this one.
Okay. Yeah, this is the one in the class and I didn't understand.
Hello.
Hello?
Yeah. So I was telling you, uh, this is the question you did not understand, right?
Yeah.
Okay. In this question, it is design the example, find J and B. Okay. Okay. Let's go to the whiteboard. And let me omega 1 by j square d by j. K value is given 5. K is given 5. You have been given overshoot 20% and settling time of 2 seconds. Okay. settling time is 2 seconds, and overshoot is 20%. You have to find the value of J and D. Okay? See very carefully here. Are you there?
Yeah.
Yeah. So this is your general formula given. It is given in your PDF. Okay.
Okay.
Now what will you do? You will compare it with standard formula. So when you compare this with this, you get omega n square is nothing but k by j. So omega n is under root k by j.
K by J or 1 by J?
K by j. Here see it is k by j. What you always do this thing wrong. I always tell you to compare the denominator. You always compare the numerator part.
Okay, okay.
So here it is 2 zeta omega n equal to d by j. Okay. And omega n is under root k by j is this. So you will have d by j into 1 by 2 into under root j by k. So here you will have j will cancel out. It would be under root d by jk. Okay. Is it fine?
I didn't get what you're doing, really.
2 zeta omega n is under root d by j. Is it fine?
Yeah.
Now, what is the value of omega n? 2
What?
zeta k by j equal to, this is, sorry, okay, this is d by j. Fine.
Yeah.
Now, 2 zeta k by j equal to, you can write j as like this, right? Okay.
Okay.
So now you can write 2 zeta under root k by under root j d by under root j into under root j. This one can got cancelled. You have zeta is equal to d by 2 under root k into under root j. So you can write zeta is equal to d by 2 under root kj. Fine.
Mm-hmm.
Understood now?
Mm.
Now see the formula. What formula did we have? Let's go back. Do you have calculator?
Sorry?
Calculator.
No, not with me.
Zeta is minus ln.
From when did you get that formula?
In your PPT. Okay. Now you have been given percentage OS is 20. So just put the values here. 20 by 100 under root pi square plus ln square 20 by 100. So now 20 by 100 is what? I do not have my calculator with myself. You will get some value here. Okay.
Mm-hmm.
Suppose you are getting 0.5. Let's suppose you
Let me
will solve this.
get my calculator just a second. Yeah, I got it. What should I put?
You put 20 by you solve this equation.
negative ln, right?
Hmm. You can write this as minus ln 0.2 upon under root pi square plus ln square 0.2, right? First calculate the denominator part, then do the division part.
Oh, I'm putting it all into calculator. Is that right?
If it supports you, then do that.
What?
I will tell you to do step by step, okay?
I did the whole thing and I got 0.455.
Okay, so this is your value of zeta. Zeta is what? 0.45, right? And since it is less than 1 and greater than 0, that means your system is underdamped. Now you got zeta value, okay? And you have been given zeta, this value is 0.45 and Tx is what? 2 seconds. This is 4 by zeta omega n. Now zeta omega n is 4 by 2. This is into omega n is what? 2 by zeta, 2 by 0.45, right?
Mhm.
Now you will solve, you will get something else. And since now here if you see, you know omega n and k value is 2, you can find j, right?
Yeah.
Similarly, if you can find j, then you know zeta, you know j value, you know k value, and you can easily find d value. Okay.
So let's do how to find the value. Let's do the example.
Okay. Find omega n.
Omega n is what?
2 by 0.45.
4.4.
How much? 4.4.
4.
Now you know omega n is under root j by k, or you can say omega n squared j by k. So you know k, j is what? Omega n square into k. That means 4.4 square into 2. Tell me the value.
38.72.
38 point.
72.
38 point. Okay,
Sev-
I did here wrong. Sorry. This is k by j. So it would be omega n square k by j. So j would be k upon omega n square. Now tell me 2 upon 4.4 square.
0.103.
0.103. Okay, you in your answer it is 0.26. Let's try to do this calculation again. Maybe there will be some problem, but it is somewhat right. Okay. There may be some calculation error. Try to do it again. I will also check the value. Okay. I do not have my calculator right now. Let me wait. Give me a minute. I just find my calculator. Okay, so here you got the value wrong. Pi 3.14 square plus ln square ln 0.2 is what? Square plus 3.14 square under root ln 0.2 divided by this. Okay, you have got it right, 0.456. Now 2 by 0.456 is 4.4. Okay, and 2 by 4.4 square is 0.103. Oh, okay. Here this value is 5. Now calculate it. You will have 5 by 4.4, which is 0.25, 0.26. Okay. Hello.
Yeah, 5 over 4.4 square
Yes.
is equal 0.25 or 26.
Yeah. 0.26. Okay.
Mhm.
Now, your zeta, now you have to find d value. So d value is what? D is 2 zeta under root kg, which is 2 into 0.45 under root 5 into 0.26. Find the value. Okay,
Mhm.
this is your answer.
Yeah, that's exactly what I got.
Fine. So this is same answer as ours. Okay.
Mhm.
Now moving to the next part. Okay, so here this is another topic, system with additional poles, right? So here what are we doing? Additional poles in zero. Yes. What? Hello?
Yeah, I hear you.
Yeah. So here what are we doing? We are adding a third pole to our two pole system. Till now we had only s square plus 2 zeta omega ns plus omega n square, right?
Mm.
But now we are adding one more pole. Okay. So what is this? The first note that only way to add exactly one more pole is for the pole to be on the real axis. That means if you are adding any pole, then it has to be on the real axis. Till
Okay.
now, what you had? You had something like this.
Yeah.
Now what are you doing? You are adding one more pole in your system, which is suppose alpha r. Okay. So we will check that what is this additional pole, how this additional pole is affecting our the second order step response. Fine.
Okay.
So we have considered three cases here for the position of third pole, and as I told you, your pole would always be on the real axis. Why on real axis? Because if it is complex, then you know that complex roots always occurs in pair, right?
Yeah.
So that's why we always need our pole on the real axis. Now see, suppose our pole is added here. Case 1 is this. Case 2 is that it is very far from my these rows.
Yeah.
Okay. And here it is very far. It is placed at infinity.
Okay.
So what do we see that the first pole is since this pole is near my second order system, so its effect will be strong. It is moving away from my original poles,
Mm.
so my response is approaching to the second order system. Okay, and here my poles are at infinity, so this system is nothing but our second order system. Okay,
Okay.
what does it mean that suppose this is your complex roots, this is your root, one pole. Okay, now if this pole this pole is its distance is either less than or equal to, if it is less than 5 times of zeta omega n, then that means it will be considered as a dominant pole. Okay, if its distance is greater than or equal to alpha, then that means it would be your non-dominant pole, and you can ignore that pole. Fine. Now here you will see that which of T2 and T3 is a better approximation of T1. This is your T1 standard transfer function given. Now here you have been given two poles. One pole is at -10 and here your pole is at -3. Okay. So first thing what we will do, we have to find zeta omega n value. So zeta omega n value we will find from T1. So 4s is here if you compare with, so 2 zeta omega n is 4. So zeta omega n is 2, right?
If you compare with the which formula?
S square plus 2 zeta omega ns plus omega n square. Okay.
Okay.
So
And
here you got zeta is omega n is 2.
number,
Okay.
right?
Now what will you do? You will multiply 5 zeta omega n. You will multiply 5 with zeta omega n. So you got 5 into 2, which is nothing but 10. Okay. Is it fine?
Yeah.
So what will you say that your T2 T2's third pole is at -10 and T3's third pole is at -3. So you will say, and you are getting here 10 value. Okay. So you will say that your T2 is better approximation than T3. Okay.
Why is better approximation though?
Because here, what is the location of pole? -10. Here, what is the location of pole? -3. If you find 5 zeta omega n, you are getting 10.
Mm-hmm.
Okay. So that means, what did I tell you? That if it is your pole and this is additional pole, if the distance between them is greater than or equal to 5 zeta omega n, then you will say that this pole is nothing but a ordinary pole.
Okay.
Suppose you have this is your second order pole and this is your one additional pole.
Okay.
Now, if distance between them is, suppose if distance between them is, suppose A. Okay, A is what? 5 zeta omega n. If this distance, if this distance is greater than or equal to 5 zeta omega n, you will say that this pole is ordinary pole and you can neglect it. You can neglect this pole.
Okay.
Suppose you have this pole and you have this pole, additional pole. This distance is less than 5 zeta omega n. So you will say that it is your dominant pole. And you can't neglect dominant pole. Okay? Is it fine? What does it mean? It means that if you have omega n square plus, suppose this is your transfer function, okay, and you have one more pole, this one, s plus n. Now here you can neglect pole because the distance between them is greater or equal to 5 zeta omega n. So you can write this as omega n s square plus 2 zeta omega n s plus omega n square. Okay. But here in this case, this distance is less than 5 zeta omega n. So if your question is, like this, so you have to write like this only. You can't neglect this. You cannot remove this pole. Okay.
Because it's less than 5, right?
Yes. Distance.
Okay.
Okay. So moving on here, can you see the, okay, wait. Can you see the PDF?
Not really. Yeah.
Now,
Yeah.
now you see here your zeta omega n value you got 2. You calculated from here. Okay. Now when you find 5 zeta omega n, it is 10. What did I told you? That if your pole location is, the distance between pole location is greater or equal to 5 zeta omega n, then you can neglect that. It is an ordinary pole.
Yeah.
Okay. So here you see what is the location, s is equal to -10. Here it is s is equal to -3. Right? So in this case, this is -10 and these are equal. So you can neglect this.
Yeah.
But here you can't neglect this part. Okay. So this T2 is approximate to T1, right?
Yeah.
Understood?
Yeah.
Okay. Now this is system with additional pole. What they say in the previous slide we discussed what happens when we add poles. Now we will see what happens when we add zeros. Okay.
Okay.
So usually you add the zero, it affects the response, but the form of the response is preserved. Fine. Means if it is something like this, so it will after adding zero, it would be something like this only. Okay.
Yeah.
Now here we have adding one here. This is your second order system, and we have added s plus a. Okay. So when we solve this, you see that okay, you just know this line that when you add zero, here your zero location is s is equal to minus a, right? So whenever you add zeros in your second order system, what happens? It does not change the relative amplitude. Okay, it only looks like a simple gain factor. You got a here. You do not need to study all these questions. If something if some questions come from this, and then I will tell you. Okay. And here it is that if we cancel 4 and 0 when they are not exactly equal. How can we cancel? Suppose in the numerator you have s plus 4 and it is 3.5. Okay.
Mhm.
So this 4 and 3.5 are not equal, but they are exactly equal. They are very close points, right? 3.5 and 4, right?
Yeah.
So when we solve this equation here, we get these values. Let's look at the system. Okay, we will see this also. If it here it is nothing. They have said that suppose here you have s is equal to minus 4 and here you have s is equal to minus 3.5, right? And here you have s is equal to minus 4 and here you have s is equal to minus 4.01. Okay. So can we cancel poles and zeros when they are not exactly equal? Here they say that when you solve this part, when you did the partial fraction, you got 1, 3.5, 3.5, and 1. Okay. So if you see that you got 1 here also, right?
Yeah.
And here you got 1 also. So 1 is very not 1 is equal to this one, right?
Yeah.
So that means here you cannot neglect, you cannot cancel this pole and this pole and this zero. Okay. But here if you see this example, here you have taken s plus 4 and here you have s 4.01. Now when you got these values k1, k2 and k3, k4, you see that this value is 0.033 and other values if you see that these values are very high, right? 5.3, 4.4, 0.87, and here you have 0.083. So these numbers are big, but this number is small, right?
Yeah.
So here when this kind of thing happen, then you can cancel the pole and zero. Okay, fine.
Yeah.
That's it.
Okay, so let me go study for it.
Yeah, study again the time response one chapter and this one. Okay, these are only formulas, and they have given everything in your PPT, right? If you know how to execute in the questions, you can easily do that. You have only to write all these formulas in your formula sheet and directly apply. You will be given, I solved one question for you, right? Similarly, you have to do every other question.
Okay.
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 So study it one to two times,
Yeah, sure.
and then if you do not understand anything, then come, because there's nothing. What I taught you yesterday, I will tell it again. That's why I was saying that why to waste time here, because if I will teach you here, then you will again go and study back. If you have a specific concept problem, then I will tell.
Sure. How much we study today?
One second. We did an hour, 1 hour.
1 hour?
Yeah.
Okay, thank you, Mohini.
You're welcome.
Thank you.
So when we will have next class?
Uh, I think so. This year, so I want to study today the whole day.
Do one thing. Study today and tomorrow morning also. Okay.
No, tomorrow morning I have classes already.
Okay. Okay. Yeah. So after the classes, you study, and then if you do not get anything, let me know. Okay.
No, I will study right now actually.
Okay. Okay. Whatever suits you. Okay.
I will study now until tonight.
Okay. Okay. Let me know if there are any problems. Right.
Thank you.
Bye. Good night.